होतं थांबलेला इकडे येतो. Hey, what's up guys? So this is my custom RC controller made with ESP32 and ESP-NOW protocol. So this is not just for controlling RC cars. It can control robots, RC bots, rovers with robotic arms, and even short range drones. So it has two joysticks, two analog joysticks, and four push buttons, and two push buttons from the joystick, like inbuilt joystick push buttons. So yeah, we will build this today, and I have added a indicator right here, like status indicator. So yeah, let's build it. So I'm using PS2 analog joysticks and some push buttons with an ESP32 to make this RC controller. I arranged the joysticks and ESP32 properly on a perf board, so it feels natural while holding and controlling it. But while building this, I actually faced a very interesting problem, and this is important if you are working with ESP32. So initially I planned to use 3 joysticks on this RC transmitter because I was planning to control a RC rover with robotic arm. But while testing with ESP-NOW, I noticed something weird. The third joystick values were not working properly. At first, I thought it was wiring issue, but after debugging, checking, I found the real reason. So, ESP32 has two ADC units. ADC1 works perfectly even when Wi-Fi is on, and ADC2 gets locked when Wi-Fi or ESP-NOW is running. And ESP-NOW internally uses Wi-Fi, even though it doesn't need internet. So, when I connected my third joystick to ADC2 pins, it worked during normal testing, but completely failed once ESP-NOW was enabled. So instead of forcing 3 joysticks and fighting for the hardware, I redesigned the controller logic. I kept 2 joysticks for proportional control and replaced the third joystick with 4 digital push buttons: forward, backward, left and right. So this made the controller more reliable, simpler and honestly perfect for ESP-NOW. After finalizing the electronics, I started crafting the outer case. My previous RC controller case was actually really cool, so I decided to build something similar again. It feels amazing in hand, very controller-like. I glued the PCB on sunboard, made a proper casing, connected 2-cell battery holder with a power switch, and the transmitter hardware was done. By the way, if you haven't seen my earlier NRF24 Plus Arduino Uno RC controller, go check it out, and it's on Instructables too. Now let's move on to the coding part. This is the transmitter code. I have initialized all the required libraries, defined all the pins according to the circuit, and created a data structure to send joysticks and button values together. Here you need to replace the MAC address with your receiver ESP32's MAC address. I will also share a small code to find the MAC address of your ESP32. In void setup, I initialize serial communication, set pin mods, initialize ESP-NOW, and register the receiver as peer using its MAC address. So check the description for all the codes and circuit diagram. In the void loop, I continuously read the joystick and button values, store them inside the data structure and send them wirelessly using ESP-NOW. That's it, simple and efficient. Now let's move on to the receiver code. This code receives all the data sent by the transmitter and prints the values on the serial monitor. Once uploaded, you will start seeing the joystick and push button values updating in real time. After uploading both codes, I immediately started getting values on the serial monitor, and that's when I knew the controller was working perfectly. Now to test this properly, I needed something real, so I built a RC car using ESP32 L2910 motor driver and BO motors. But before going outside, let me explain ESP-NOW in very short. ESP-NOW is a low latency peer-to-peer wireless protocol by Espressif. It allows ESP32 boards to communicate directly without internet or Wi-Fi, and it's extremely fast with low latency. So ESP-NOW is a very good option for controlling robo soccer, robo race and robo or bots. Okay, now let's go outside and test this RC controller. And yeah, it works so smooth, responsive and exactly how I wanted. As per the Google, the typical ESP-NOW range is around 100 to 200 meters. But I tested this controller inside my college campus with a lot of Wi-Fi interference, and it worked smoothly even at 10 to 15 meters with very low latency. I still haven't tested its maximum range yet, so I'll be doing a proper long range test in upcoming videos. Stay tuned. If you like this project, don't forget to like, subscribe and follow. Full code and circuit and explanations are all in the description. And let me know in the comments what should I control next with this RC controller.